Let's now meet one of the primitive data types that we never talked about before, and that is BigInt. So BigInt is a special type of integers that was introduced in ES 2020. And so let's quickly take a look at it. So we learned in the first lecture of the section that numbers are represented internally as 64 bits. And that means that there are exactly 64 ones or zeros to represent any given number. Now, of these 64 bits, only 53 are used to actually store the digits themselves. The rest are for storing the position of the decimal point and the sign. Now, if there are only 53 bits to store the number, that means that there is a limit of how big numbers can be. And we can calculate that number. So that's 2 elevated to 53, and then minus 1 because the numbers start at 0. And so that is this gigantic number right here. And so this is essentially the biggest number that JavaScript can safely represent. Okay? Or actually it's 53. So this is the biggest number. All right? And it is 2 because, again, we are working with base 2, which is only zeros and ones. And this number is so important that it's even stored into the number namespace as max save integer. So this gives us the exact same number. All right. So any integer that is larger than this is not safe. And that means it cannot be represented accurately. So let's duplicate this line here. And for example, add 1 to this. And so you see that this is not correct, right? It only added one number to this one where it should have been added 2. So if we do this, then we get the exact same thing. So we keep adding numbers here, and they are always the same. And so that means that JavaScript can simply not represent these numbers accurately. And so if we do calculations with numbers that are bigger than these, then we might lose precision. Okay? So in some numbers, it does actually work for some reason, but that's because JavaScript behind the scenes uses some tricks to still represent some of the unsafe numbers. But again, sometimes that works, sometimes it doesn't. And so that's why we call these unsafe numbers. So you see, sometimes these numbers are, or at least look correct, and sometimes they don't. Okay? So this can be a problem sometimes because in some situations we might need really, really big numbers, way bigger than this one here. For example, for database IDs or when interacting with real 60-bit numbers. And these numbers are actually used in other languages. And so we might, for example, from some API, get a number that is larger than this, and then we have no way of storing that in JavaScript. At least not until now. Because now, starting from ES 2020, a new primitive was added, which is called BigInt. All right? And BigInt stands for big integer, and it can be used to store numbers as large as we want. So no matter how big. All right, so let's say we need this number, and I'm just using random numbers here. So if I log this, then you see, well, this here, which probably does not have precision because, of course, it's larger than this. But if I use the n, then this will be a big int. So let's see that. And so this n here basically transforms a regular number into a big int number. And you see in the console here, it then also does look different. Okay? So this is a really, really huge number. But now JavaScript has a way of finally displaying this number here accurately. All right? We can also create big ints by using the BigInt function. So sometimes that's necessary. And then without the n. And so this gives us kind of the same result, Well, not really for some reason, but I guess it is because JavaScript will first have to still represent this number here internally before it can then transform it into a big int. And that's the reason why here from a certain point on, this second number is different. So this constructor function should probably only be used with small numbers. For example, like this. Okay, so this is how we create big int numbers. But let's now see some operations with these numbers. And, well, basically it's very simple. All the usual operators still work the same. So let's say we have 1 or 10,000 n plus 10,000 again. And so in this case, of course, we wouldn't even need a big int here, but this is just to demonstrate that the operators work just the same with big int. So we get indeed 20,000. And the same is true with other operations. So for example, a multiplication, let's try a really huge number, 10 times this other huge number, and so it then gives us this result. Now, what is not possible is to mix big ints with regular numbers. So let's say we have huge, so some random number like this, and then we have a regular number, which is just 23. And so if I wanted to multiply them, so huge times num, then we would get this error. Cannot mix big int and other types. All right. And so this is where we then would have to convert this number here to a big int. And this is where the constructor function that I showed you here becomes necessary. And so now it is indeed going to work. However, there are two exceptions to this, which are the comparison operators and the plus operator when working with strings. So let's see that. So we can still do a big int and then, for example, greater than a normal number. So this still works and we still get true as expected. Okay. However, when we do this, so 20n equal 20, we will get false. But that makes sense because JavaScript, when we use the triple operator, does not do type coercion. And in fact, these two values here, they have a different primitive type. This is a regular number and this is a big int. In fact, we can check that, or at least I think we can. I never did this actually. But yeah, indeed, the type of this is a big int. All right. But however, if we do the regular equality operator, so the loose one, then this should still be true, right? Because then JavaScript does the type coercion, and so then it will coerce this one to a regular number, and then they're both the same. So just like, so it would even work like this. So this is one exception. Let's write that here. So logical operators are one exception, and the other exception is when we do string concatenations. So let's say huge plus, and then some string here is really big. And so you see, in this case, the number is then actually converted to a string. So even the big int number. Okay. Now, one other thing that I didn't tell you up here is that also the math operations that we talked about earlier are not going to work here. For example, we cannot take the square root like this, qrt of 16n. All right, so that doesn't work. All right, finally, let's take a look at what happens with divisions, because big int is indeed an integer. So what happens if we do this? 10 divided by 3n. And we know that with normal numbers, this would not be an integer, right? So 10 divided by 3 is 3.33 until infinity. So here. But with big ints, it will simply then return the closest big int, right? Let's try it with 11 here. And so it simply basically cuts the decimal part off. Of course, with 12, it would then be 4, right? But with anything else, it will then cut off the decimal part. Okay, and basically, this is all that I have to tell you in an introduction video like this one about BigInt. So this new primitive type adds some new capabilities to the JavaScript language when you really need to work with like huge numbers, just like this one here, for example. Now in practice, you will probably not use this very much, but it's still good to know that BigInt exists and also how it works.